Time for some empirical formula, molecular formula review. You should have read through the notes, and you see that you essentially have to do some real simple molar mass conversions and then find a mole ratio. That's what empirical formulas are always about. So we're going to always start with our givens, which are 73.9 grams of mercury. You need that value to be in moles. So the first thing we're going to do is convert that into moles. The molar mass of mercury is 200.6 grams. When you divide that out, you're going to get 0.36839. Notice I used 5 sig figs on this problem. The reason why I used 5 sig figs is just for consistency reasons. I don't want to write out every single number. So in problems where you have an intermediate answer, so this is not going to be our answer, so I call it an intermediate answer. We always want to go 2 sig figs past however many was our least number in our problem. So we had 3 sig figs and 3 sig figs given in the problem, so I'm going to always do my intermediate answers to 5 sig figs. So that gives me the mole value for mercury. I'm going to do the same thing for chlorine using its molar mass. So in every 1 mole of chlorine, there's 35.5 grams. And I'm going to put 5 sig figs again for my unrounded intermediate answer. Okay, so it looks like that. Now you're going to decide which of those two values is the smallest, which is obviously the mercury value, and you're going to divide both of them by the smallest value. So when you divide this one by itself, we're going to get 1. And when you divide this one by 0.36839, you end up with a 2. And those are your coefficients for your substance. So mercury is going to have a 1, and chlorine is going to have a 2. And that is your empirical formula for this problem. So convert grams to moles, do a mole ratio. That's how you do empirical formula. So we're going to go ahead and do this next problem. Starting, so this time we have 4 different substances. So I'm going to have 49.798 grams of carbon. We convert that using its molar mass. I get 4.14983 moles of carbon. 28.532 grams of nitrogen. Notice I'm not using the diatomic molar mass because this nitrogen is in a compound. When it's in a compound, it won't be diatomic. It's only diatomic when it's by itself. So that will be nitrogen. Then I'm going to do 5.082 grams of hydrogen. That one's nice and easy. Gotta squeeze in this other one, so 16.288 grams of oxygen. For every 1 mole of oxygen, there's 16.0. So I get an unrounded answer of, calculator is freaking out on me here. Unrounded answer of 1.018 moles oxygen. So of those, the smallest one looks like it's the oxygen one. I'm going to divide them all. I usually just work it right into my work. When you divide that one, you get 4. Sometimes it's not going to be exactly the whole number, but as long as it's within 0.1 of the whole number, it's okay to round it. So all of these come out to be within 0.1 of a whole number. So we are able to round those without any issue. And then I'm going to divide this one by itself. So we end up with 1. So the coefficient, silly me, the subscript on carbon is a 4. For nitrogen, it's a 2. For hydrogen, it's a 5. And for oxygen, it would be a 1. And that is the empirical formula. Remember, empirical formula is most reduced form. All right, for the next problem, we're doing vitamin C. Now we have 3 different substances, but notice this time they've given us percent signs. The percent signs are really easy to deal with. All you're going to do is cross off the percent sign and turn it into a gram sign. because if we had 100 grams, then those percentages would be equivalent. Makes it much easier for a problem. So we're going to do 40.92 grams of carbon, converting that into moles. I get 3.41 moles of carbon, and then we have 4.58 grams of hydrogen. Every 1 mole, it's 1.0 grams. Gives me 4.58 moles of hydrogen. And then I have 54.5 grams of oxygen. So I put the molar mass in, and that gives me 3.40625 moles of oxygen. Look for the smallest one, which is the 3.40 value with oxygen. So I'm going to divide 625. That comes out to be a 1. We divide this one. Now, this is going to give us a little bit of a problem. When you plug this into your calculator, you end up getting 1.34. 1.34 is not within 0.1 of a whole number, so we cannot round it. We're going to have to do something to it, but let's leave it for now. Do the final division. You're dividing this by itself, so of course it's going to come out to be 1. Now we need to deal with that value that wasn't within 0.1. Again, if it's within 0.1 of a whole number, round it to the whole number. This one is not. What you need to do is find a value that you could multiply all of them by and end up with whole numbers for all of them. In this case, since 0.34 is essentially a third, the number that we're going to use is times 3. And when we do that, it gets all of our values within 0.1 of a whole number. So this one comes out to be 4, this one comes out to be 3, so you have C3H4O3. Okay, so change your percent signs to gram signs. Keep an eye out for when you do your ratio portion. If it's not within 0.1 of a whole number, you have to go back and deal with that. And the way you deal with that is by multiplying them all by the same value. That gets them all into being whole numbers. So let's take a look at the last problem. Maybe it'd be a good idea to pause the pencast at this point and do this problem for yourself. Okay? You can come back and test to see if you are getting it. So I'm converting my grams to moles. You end up with 1.26435 moles of Na. And then we have 40.56 grams of sulfur. Every 1 mole, 16.0 grams. And that is 1.26355. And then for oxygen, 30.36 grams of oxygen. Oops. Silly me. This should say 32.1 grams, and that number is right. I just wrote the wrong thing. And you end up with 1.8975 moles of oxygen. So the smallest is going to be our 1.26355. So you divide this one. Comes out to be 1. You divide this one by itself. Obviously 1. You divide this one. Once again, we get a number that's not within 0.1 of a whole number. So it's going to be 1.5. Can't have a decimal as a subscript. So our multiplier here is going to be 2. And that's going to get all of these values to whole numbers. So your answer is Na2S2O3. So that's empirical formula. The next lesson we'll cover how to deal with molecular formulas from empirical. Empirical are the most reduced. Molecular are going to unreduce those reduced.